So this is our third and final method of solving a system of linear equations, and we're going to use what we call the addition method. Sometimes you'll also have it heard to as the elimination method. They're the same exact method. So if you see addition or elimination, you're doing the exact same thing. So in this method, we're going to be given again two equations with both x and y and a constant. Now for the elimination method, they need to be in standard form. Standard form just means that both your x and your y are on the left-hand side of the equation and that they line up with each other. So notice here both my x's line up with each other, both my y's are lined up with each other. They're both on the left-hand side of my equation. On the right-hand side is my constant or my single number. And what we're wanting to do is we're wanting to make the coefficients of one set of variables the same, but opposite signs. Okay, so for instance, let's just say that I had these two equations, and then I had what I want to do. For instance, let's say that I want to get rid of or eliminate my x's here. What I want to do is I want to find the least common multiple between 2 and 5. Now when we talk about the least common multiple, what we're talking about is we want a number that we can build both 2 and 5 up to. So remember, you're getting larger than these numbers, not smaller. So the least common multiple between 2 and 5 would be the number 10, because I can multiply 2 times 5 and that gives me 10. I can multiply 5 times 2 and that also gives me 10. Now I'm choosing to use 10, which is the smallest number. However, if you said 20, that's okay too. As long as you can multiply both numbers to that number, you're going to be okay. Now what I want to do is I want to go, okay, so I need this guy to be a positive 10. So I'm going to multiply him, and when I say him, I mean the entire equation, by the number 5, because 5 times 2 would give me that 10 that I'm looking for. So we would come over here, and this would be 10x plus 15y equals 20. And then we would say, okay, now I want this particular x to be a negative 10, because remember, I want them to be the same number but opposite in signs. So I need one to be positive, one to be negative. Doesn't matter which one's positive or which one's negative, I just need one of them to be a negative number. So since this guy, I made him a positive 10x, I need to make this guy a negative. So we're going to multiply by negative 2. Again, the entire equation gets multiplied by negative 2. So that would give us negative 10x plus 4y equals negative 12. Okay. Now what this does, and the reason we're wanting to do this, and I'm not going to finish this problem out, but I just want you to see what's happening. When I take, and this is why it's called the addition method, because once I get my two terms opposite of each other, one a positive 10, one a negative 10, I'm going to take these two equations and I'm literally going to add them together. That's one of the reasons we want them all nice and lined up, so that we can go, okay, 10x minus 10x cancel each other out, so I don't have any x's anymore. I've eliminated my x variable. Again, this is why sometimes you hear this called the elimination method. So then I'm going to take and add these guys together. That's going to give me 19y. And I'm going to subtract 20 minus 12, which would give me 6. And then I would go through the process of actually solving for y. Once I solve for y, I would substitute that back in and find my x. So again, we want to make our coefficients opposite of each other. Once we have that, then we get to add the two equations. And we solve for the variable. And then lastly, we substitute into one equation to find the other variable. So you're still going to be doing that substitution that you did in the first problem. It's just going to be a little bit different starting off. But again, the biggest thing on this is making sure we get those opposite coefficients for one set of variables, and it really doesn't matter whether you do the x or y. That's the beauty of this, is you get to look at the variables and say, I really think I'd like to cancel out the x's, or I really think I'd like to cancel out the y's, and you get that choice. Okay, so for our first example, you'll notice when you look at the problem, it doesn't look any different than what we were doing in 10.2, or solving using substitution. So the problems look exactly the same. It's just the method that we're looking. Again, we're doing our addition method, so we want to eliminate one set of the variables. And then for this particular problem, if you'll notice, your x's here are already opposite of each other. You've got a negative 4x and a positive 4x, so they're actually already opposite of each other, and that would probably be the easiest thing to eliminate. We wouldn't even have to make anything the same because they already are. We could use the y's. The LCM between the y's would be 4. I just want to multiply this guy by negative 4 so that my y's would be opposite of each other. But like I said, my x's are already there. I don't really want to reinvent the wheel. So let's just go ahead and say we're going to eliminate our x's. Again, it's already set up for us, so that makes it a whole lot easier than trying to do it the other way. Again, adding my two equations together, my x's here are going to cancel completely out, which is what I'm wanting to happen. Remember, I'm wanting one variable to completely go away. And here we're going to say 5y equals negative 15. Remember, watching your signs, making sure we've got all those signs correct. We're going to divide both sides by 5. And y is equal to negative 3. So remember, when we're doing this, we're having to find both the x and the y. We don't just want one value, we want them both. Once we find one, though, all we have to do is pick one of the two equations to plug back into, and we'll find our x. And this is the really cool thing, is it doesn't matter which equation you plug the y into. You're going to find the same x either way, because remember, this is the point where these two lines cross, or this is the point they have in common. So again, it doesn't matter. I like this first equation because I just have a single y. I don't have to do any kind of multiplication to plug this in. So I'm going to plug my negative 3 into that y, since that's what I just found, and let's find our x. So we're going to take this guy, and we're going to take it into that negative 4x plus y equal to 1. So we have negative 4x. Now if I do plus a negative 3, that's going to make that a minus 3, or you could put plus a negative 3. I just don't like having two signs right there together. Now let's solve for x. So we're going to add 3 to both sides. So I get negative 4x equals 4. Divide by negative 4 on both sides. And x equals negative 1. So now I have both my x value, I have my y value, so I do have what we call one solution. Okay, and remember, we're going to write this as the point negative 1 comma negative 3. Remember, when you're writing it as a point, always place your x first, followed by your y. Okay, so for our second example, we have our first equation being negative 8x plus 4y equal to negative 16, and then our second equation is 5y equals 5x minus 20. Now what I want you to notice is on this second equation, we need to change it to standard form. Remember, again, all standard form means is both x and y are on the left, which means for us that this this 5x needs to be moved by subtracting or making that a negative 5x. And when you do this, notice that my placement of it is I want it to line up with my negative 8. So when I move it, I'm going to put it in front of my 5y. I want my x's to line up, I want my y's to line up. So my first equation, I'm not changing. This is going to stay negative 8x plus 4y equals negative 16, but now when I move my 5x over, this is going to be a negative 5x plus 5y equals negative 20. Okay, again, just making sure that both my x's and y's are on the left hand side and that they are lined up with each other, so that when I do my get my opposite coefficients, then I can add those two equations together and cancel out my either x or y. So let's eliminate our y's this time. We've been kind of focusing in on x's a lot, so let's do our LCM between 4 and 5. So the smallest number I can build both 4 and 5 up to is 20. Okay, so that's my least common multiple between 4 and 5. Again, remember, least common multiple, I'm building up to that multiple. I want a number that both 4 and 5 will divide into. So on the 4y, to make him 20, I'm going to multiply this entire equation by 5. So as we do that, that's going to give us negative 40x. That's going to give us a positive 20y. And 5 times 16 is going to give us a negative 80. All right, now he is a positive 20. Remember, I not only want them to be the same number, I want them to be opposite signs. So I need this 5y to become a negative 20. So what do I need to multiply by 5 to get to negative 20? So we would need to multiply this by negative 4. So that would give us a positive 20x, a negative 20y, and that would give us a positive 80. All right, so we're going to add these together. Now, my x's don't cancel because remember I was canceling my y's out. So I've got negative 40 minus 20. That's going to give me negative 20x. My y's do indeed cancel. Remember, that should always happen. That's what I'm trying to get rid of. Equals 0. There's nothing wrong with this thing equaling 0. We want to continue to solve. We have an x. So we're going to divide by negative 20 on both of these. And we have found out that x is equal to 0. And again, there's nothing wrong with x equaling to 0. It's a perfectly fine answer for us. So we've got that. Now we want to take this guy back and plug him into one of these two equations. I'm going to choose to plug it into the second one. And also notice that I'm always going back to my originals up here, not to where I changed them. Okay? So I'm going to plug it into this second one. We've got 5y equals 5x minus 20. So 5y equals 5 times 0 minus 20. So 5y equals 0 minus 20. Well, that means 5y equals negative 20. And I'm going to divide both sides by 5. And y equals negative 4. So now I have my x value, I have my y value. Again, since I do have a value for both x and y, this is one solution. These two lines actually are crossing. And remember, I'm just going to do my x first. So 0, comma, negative 4, and this is my answer.